smallest size of aluminum wire permitted for electrical wiring is 14 AWG. This is an important consideration when selecting conductors for various electrical applications. Aluminum wire, while offering advantages such as lighter weight and low cost compared to copper, has different properties that necessitate careful attention to sizing and installation practices. Firstly, aluminum has a higher resistance than copper. This means that for the same current carrying capacity, an aluminum wire must be larger in diameter than a copper wire. This is why the minimum size is specified as 14 AWG. Using a smaller size aluminum wire could lead to excessive voltage drop and overheating, posing a safety hazard. Secondly, aluminum is more susceptible to oxidation. When aluminum is exposed to air, it forms a layer of aluminum oxide on its surface. This oxide layer is non-conductive and can increase the resistance of connections. To mitigate this, special connectors and termination techniques are required when using aluminum wire. These connectors are designed to penetrate the oxide layer and establish a reliable electrical connection. Thirdly, the National Electrical Code, or NEC, provides guidelines and regulations for electrical installations, including the use of aluminum wire. It's crucial to consult the NEC to ensure compliance with all applicable requirements. The NEC specifies ampacity ratings for different wire sizes and insulation types, taking into account factors such as ambient temperature and the number of conductors in a raceway. When selecting aluminum wire, it's essential to consider the specific application and the environmental conditions. For example, the ampacity of a 14 AWG aluminum wire may vary depending on whether it's installed in a dry location or a wet location. It's also important to note that aluminum wire is generally not recommended for certain applications, such as direct burial or use in corrosive environments. In these cases, copper wire may be a more suitable option. Furthermore, the type of insulation used on the aluminum wire can also affect its performance. Common insulation types include THHN, THWN, and XHHW. Each insulation type has different temperature ratings and resistance to moisture and chemicals. When working with aluminum wire, it's crucial to follow proper installation techniques. This includes using appropriate connectors, applying antioxidant compounds, and ensuring that connections are properly tightened. Loose connections can lead to overheating and arcing, which can pose a fire hazard. Additionally, it's important to avoid mixing aluminum and copper wires in the same circuit, as this can lead to galvanic corrosion. Galvanic corrosion occurs when two dissimilar metals are in contact in the presence of an electrolyte, such as moisture. The aluminum will corrode preferentially, weakening the connection and potentially leading to failure. In summary, the smallest size of aluminum wire permitted for electrical wiring is 14 AWG due to its high resistance and susceptibility to oxidation. Selecting the appropriate wire size is essential for ensuring electrical safety and compliance with the National Electrical Code. Always consult with a qualified electrician or electrical engineer when designing or installing electrical systems using aluminum wire. Remember to use appropriate connectors, apply antioxidant compounds, and follow proper installation techniques. Aluminum wire is a viable option for electrical wiring when properly installed and maintained, but it's crucial to understand its limitations and take necessary precautions. Firstly, always check local electrical codes. Local codes might have stricter requirements or specific restrictions on aluminum wire use. Secondly, consider the load requirements. Ensure the 14 AWG aluminum wire is adequate for the intended circuit load. Overloading can cause overheating and potentially fire. Thirdly, inspect existing wiring. If replacing existing wiring, carefully inspect the condition of the existing aluminum conductors and connections for signs of corrosion or damage. Fourthly, use proper tools. Use tools specifically designed for aluminum wire termination to ensure proper crimping and connection. Fifthly, apply antioxidant compound. Always apply an approved antioxidant compound to the aluminum conductor before making a connection. This helps prevent oxidation and ensures a good electrical contact. Sixthly, tighten connections properly. Use a torque wrench to tighten connections to the manufacturer's specified torque to avoid loose connections. Seventhly, avoid dissimilar metals. Avoid direct contact between aluminum and copper conductors or connectors to prevent galvanic corrosion. Eighthly, label appropriately. Clearly label circuits using aluminum wire to alert future electricians or homeowners. Ninthly, regular inspection. Periodically inspect aluminum wire connections for signs of loosening or corrosion. Tenthly, consider professional installation. If you are not comfortable working with aluminum wire, hire a qualified electrician to perform the installation. In addition to these points, consider that the ampacity of aluminum wire is different from that of copper wire of the same gauge. The National Electrical Code, or NEC, provides ampacity charts for various wire types and sizes. Always refer to these charts to determine the correct wire size for a given application. For example, a 14 AWG copper wire may have a higher ampacity than a 14 AWG aluminum wire. This difference in ampacity is due to the higher resistance of aluminum. When selecting aluminum wire, it's important to choose a wire type that is suitable for the intended environment. For example, THHN wire is commonly used in dry locations, while THWN wire is suitable for wet locations. The insulation on the wire helps to protect it from moisture, chemicals, and abrasion. It's also important to consider the voltage drop in the circuit. Voltage drop occurs when the voltage at the load is lower than the voltage at the source. Excessive voltage drop can cause equipment to malfunction and can also lead to overheating of the conductors. The amount of voltage drop in a circuit depends on the length of the wire, the current flowing through the wire, and the resistance of the wire. Aluminum wire has a higher resistance than copper wire, so it will experience a greater voltage drop for the same current and length. To minimize voltage drop, it's important to use the correct wire size and to keep the circuit length as short as possible. You can also use a higher voltage to reduce the current and therefore the voltage drop. Remember that aluminum wire expands and contracts more than copper wire with changes in temperature. This can lead to loose connections over time if the connections are not properly made. When making connections with aluminum wire, it's important to use connectors that are specifically designed for use with aluminum. These connectors are typically made of aluminum and have a special coating that helps to prevent corrosion. It's also important to use a torque wrench to tighten the connections to the manufacturer's specified torque. Over-tightening or under-tightening the connections can lead to loose connections and overheating. Finally, it's important to be aware of the potential hazards associated with working with electricity. Always disconnect the power before working on any electrical circuit. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Aluminum wire is commonly used in residential and commercial buildings for branch circuits and feeders. It's also used in some industrial applications. However, it's important to follow all applicable codes and standards when using aluminum wire. The NEC provides detailed requirements for the installation of aluminum wire, including requirements for wire size, ampacity, connectors, and grounding. The NEC also includes requirements for the inspection and testing of electrical systems. Electrical systems should be inspected and tested regularly to ensure that they are safe and operating properly. The inspection should include a visual inspection of the wiring, connections, and equipment. The testing should include tests of the insulation resistance, ground resistance, and voltage drop. If any problems are found, they should be corrected immediately. Additionally, always refer to the manufacturer's instructions for specific guidance on the installation and use of aluminum wire and connectors. Following these instructions is essential for ensuring a safe and reliable electrical system. When selecting aluminum wire, it's also important to consider the cost. Aluminum wire is typically less expensive than copper wire, but the cost savings may be offset by the need for larger wire sizes and specialized connectors. You should also consider the long-term costs of maintenance and repair. Aluminum wire is more susceptible to corrosion than copper wire, so it may require more frequent maintenance. Keep in mind that using the correct size and type of wire, along with proper installation techniques, is essential for ensuring the safety and reliability of electrical systems. By following these guidelines, you can minimize the risks associated with using aluminum wire and ensure that your electrical system operates safely and efficiently.